Yes, okay. Thank you for the introduction. My name is Jean-Pierre Janin. I am a geotechnical engineer of Setec Terrasol, and I'm a referent of underground projects. Setec is a French independent multidisciplinary engineering group that designs and follows different and complex projects all over the world. It was created in 1957, and today it employs 2,500 collaborators. In Setec, there are different branches, and Terrasol is the branch specialized in geotechnical issues and soil structure interaction problems. So, Terrasol can study different kinds of projects. So, metro, underground tunnels, the foundation of bridge, foundation of big tower, slope, soil slope stability, and dynamic problems. And we intervene in all phases of a project, from upstream phases to design phases to project management and also expertise. And we are a lot involved too in the scientific community, because we are present in the national and international working groups, and we publish, for instance, 20 papers per year in scientific journals and congress. So, today I want to present you the project of the adaptation of an existing subway station, the Mairie de Lilas station, in the line 11 Paris metro. This project is a part of the new line 11 extension to the east of Paris. And this extension this project is related to the big project of the Greater Paris. So here you can see the new line metros for the future of Paris. The main characteristics of this extension are 6 new kilometers, 6 new stations, an important increment of users. The project owner are RATP and Île-de-France Mobilité, and the global cost is about 1.3 billion of euro, including 200 million of euro for the adaptation of existing line and stations. Well, the project of the adaptation of Mairie de Lilas station concerns the realization of 2 new access points. So here you can see the principal axis, new principal axis, and the new secondary axis to the existing station realized in 1937. The main works consist in the realization of shafts from the surface and then tunnels, underground tunnels, to intersect the underground existing structures. The global cost is about 15 million euro. The works are planned to be completed in 2020. And a very important element is that the metro line and the station remain open during the works. Well, the RATP, the owner of the project, for the design of these 2 new accesses, asked to answer to different goals. The first goal was to establish a geological, hydrogeological, and geotechnical model. Then, to design the 2 new accesses, and to justify the temporary supports of the new works, principally the shafts and the tunnels. Another goal was to assess the works' effects to the existing structure, the metro line, the station, and also the buildings, the roads, and other structures. And to define monitoring system for each structures. And finally, to help the RATP to prepare the tender documents. So what were the main challenges of this project? To resume, the first was the very complex soil structure interaction between the new works and the existing structures. The second challenge was the specific 3D characteristics of this project. And finally, the need to answer the best way to the different goals asked by the RTP, in particular, to give realistic results, to optimize the project, and to minimize the risks. So, to deal with these different issues, the 2D usual numerical calculation approach based on plane strain analysis in this case was not appropriate. In this case, the 3D approach, numerical approach, is very, very essential. But as we will see, it needed to create two very complex models, 3D models, in terms of geometry, in terms of mesh, in terms of calculation phase and calculation time. So the first choice was the numerical code. What numerical code use? And the choice fell on Plaxis 3D, the new entry of the entry. And why Plaxis 3D? I can resume three main reasons. The first reason is we needed to simulate correctly the soil behavior in order to give reliable estimation of works effects. And in Plaxis, there is a soil model, the hardening soil model. I resume here. And this model proved in the past in our society and for me to be able to well simulate the Paris soil layers. In this case, the soil layers are clay, marl, limestone. The second reason is given the 3D geometry, very complex 3D geometry, and a limited study time, we needed automatic mesh, but also robust and reliable mesh. And finally, in the case of very complex project, I think that it's very important to have a quite familiarity with the numerical code. And personally, I started to use Plaxis in the first version, the first 3D version in 2008. Well, after the choice of the code, after establishing the geotechnical model, it's an important part, the first challenge was to understand the complex 3D geometry of the existing structures, realized in 1937. And we had only the historical drawings. So it was not so easy. And then, in collaboration with the RATP, we could start to design the new accesses, here some the new accesses, in terms of geometry, in terms of construction method, and phasing of works. And we could realize the CAD drawings necessary then to prepare the 3D Plaxis models. And given the quite important distance between the two new axes, we decided to realize two 3D models. So, here, this picture, you can see the first model to simulate the principal axis. So, we had to model the real geometry of the existing underground structures, the station, the metro line, and also the ticket room and the connection gallery. To model the existing buildings with their position, their load, and then we modeled the new works in color one. So composed in this case by shafts and then underground tunnels to intersect the existing structure and create the new exit. With this video, I show you how it was possible, thanks to Plaxis 3D, to simulate the real phasing of work. So the excavation of each step of the shaft and of tunnel, and the installation of the temporary support. In this case, temporary support is composed by ribs, struts, shotcrete. Okay. And here, the second Plaxis 3D model for the secondary access. Same, we modeled the existing underground structure, so the station, the line 11 metro. In this case, there is also a problematic main sewer and the position of the different buildings near to the project. And the new works. And a video, in this case, the works consisting in a realization of a diaphragm wall, a first shaft next to the diaphragm wall, then a horizontal gallery. Now, we could simulate each step of each work, and then the excavation of two underground shafts to intersect the station and create the new exits. Okay. Now I show you how it was possible, thanks to the numerical Plaxis 3D model, to answer to the different goals asked by the client. One goal was to justify the temporary support of the new works. And thanks to the structural elements adopted in the model, so like a beam, like plates, we could justify the support of shafts and tunnels. For instance, here you can see the bending moment in the ribs of the shaft and the ribs of the tunnels. Another important thing was to predict the tunnel support displacement against the phase of work. The second principal main goal was to justify, estimate the works effect on the existing underground structures. I remember you that the station and the metro remain open during the works. And so with the 3D modelization, we could study the displacement caused by the works on the station, on the metro. We can identify the most critical zone will require a very special attention during the works because the station remains open. And another important thing was to estimate the stress variation in existing lining between before the works, new works, and after at the end of the new works. Here, for instance, the stress in the lining of the station and in the metro, we could analyze where, for instance, the traction could increase. Another important goal was the prediction, settlement prediction for the road and for each buildings. And thanks to the 3D modelization, we can study the settlement of each building and identify the area with strong settlement, in this case is here, and determine the most critical works phases against settlements. Based on all these results, we could, in collaboration with the client, define a monitoring system for each structure and the displacement thresholds. And their thresholds enter in the tender documents. For instance, here you can see the view on the top, and is the position of the target prism for the road and for each buildings, and we define, for instance, for the road, these thresholds. The same for the underground structures. We could define where the convergence will be measured and the thresholds for these displacements. Well, the complexity of this project needed to adopt a 3D approach. So it's essential. But it needed also to realize two very, very complex models with Plaxis. Today, I can say that the challenge was raised. Why? Because first, we could, with 3D Plaxis modelization, justify the feasibility of the project. In this case, if you use a 2D usual approach, you often obtain unrealistic and excessive settlements. Sometimes you can't justify the project. And the second thing that we optimize the project works in terms of supports and construction steps. For instance, we could justify the full face excavation of this new tunnel and not divided excavation. And we could improve the project reliability, the security, and safety with the determination of the most critical construction phase and the definition of monitoring system for each work and thresholds for each work. So all these permits to justify the project and to reduce the project cost and delay. But for me, it's very, very essential to remember that even the most complex 3D numerical model remain always a simplification of the reality. With the ground it's true. And so it's very essential to compare the numerical prediction, also 3D numerical prediction, with in situ observations. And now we have the luck that the first new access is under construction. The excavation phases are almost complete. Here you can see the principal, the big shaft. You can recognize the big shaft we modeled in Plaxis, the big tunnel and the little tunnel. And the in situ observation confirm, one, the geotechnical model, and the low impact on underground existing structures, and the low settlement on buildings and roads. So thank you very much for your attention, and I want to thank the RATP and also my colleagues, Ayub and Johan, who worked with me in this project. Thank you.
Thank you.